What if I told you the next major conflict might have zero human soldiers on the front lines? Imagine battlefields where machines fight machines, while humans monitor from thousands of miles away. Sound like a sci-fi movie? It's happening right now. Military robotics has exploded beyond what most people realize. And the 15 robots I'm about to show you aren't prototypes or concepts. They're already changing warfare forever. Are you ready to see the army of tomorrow that's being built today? 1. Bayraktar TB. 2. What happens when a relatively small drone takes on tanks that cost millions? The answer shocked military experts worldwide. The Turkish-made Bayraktar TB2 has rewritten modern warfare's rules. This unassuming aircraft costs about $5 million, a fraction of traditional combat aircraft, yet it's changed the face of conflicts from Ukraine to Libya. Flying for 27 hours straight at 25,000 feet, the TB2 stays beyond the reach of most ground defenses, while its cameras spot targets up to 200 kilometers away. When it's time to strike, it delivers laser-guided bombs with surgical precision. What makes the TB2 revolutionary isn't just what it can do, it's the barrier it's broken. Countries that could never afford advanced air forces now have access to game-changing air power. In Nagorno-Karabakh, TB2s systematically destroyed Armenian air defenses and armor. In Ukraine, they've taken out Russian command posts and supply convoys. The biggest shock? The TB2 proves you don't need billion-dollar programs to dominate modern battlefields. For military leaders worldwide, that realization has been a wake-up call they can't ignore. 2. Ghost Robotics Vision 60. What if you could build a guard dog that never sleeps, never eats, and can be equipped with anything from thermal cameras to weapons? Meet the Vision 60, the robotic dog currently patrolling U.S. Air Force bases. This quadruped robot from Ghost Robotics moves across terrain that would stop wheeled or tracked vehicles dead. Stairs, rocks, sand, snow, nothing slows it down. Standing 2.5 feet tall and weighing 70 pounds, the Vision 60 can run at 7.5 miles per hour for 3 hours on a single charge. But what sets it apart is its adaptability. Need surveillance? Attach cameras? Need firepower? Sword Defense Systems has created a special-purpose rifle that turns the Vision 60 into an armed sentry. The U.S. Air Force has already deployed these robots at Tyndall Air Force Base, where they patrol perimeters autonomously, scanning for intruders and potential threats. If something doesn't look right, they alert human operators who can take control remotely. The Vision 60 isn't just a cool tech toy, it's reshaping how we think about security in high-risk areas. Would you rather send a human patrol into a danger zone or a robot that can see in the dark and doesn't fear ambushes? 3. Sea Hunter. The oceans cover 71% of Earth's surface. Monitoring them has always been a massive challenge until now. The Sea Hunter is unlike any vessel ever built. This 132-foot trimaran has no crew quarters, no galley, no bathrooms. Nobody's on board because nobody needs to be. It can hunt submarines and patrol waters for months, completely autonomously. Built by DARPA and Leidos, Sea Hunter costs just $20 million, a tiny fraction of the $1.6 billion price tag of a modern destroyer. And it only costs about $15,000 to $20,000 per day to operate compared to $700,000 for a guided missile destroyer. The real breakthrough? Sea Hunter became the first ship to autonomously navigate from San Diego to Hawaii and back a 4,000-mile journey. No remote operators, no safety crews, just artificial intelligence making thousands of decisions on its own. What does this mean for naval warfare? Imagine fleets of hundreds of these vessels networking together, hunting enemy submarines or patrolling strategic waterways. The U.S. Navy is already building larger versions. The age of autonomous naval warfare has begun, and Sea Hunter is leading the charge. 4th Perdix Swarm Drones. What's more dangerous than one drone? How about 103 drones that think and act as a single entity? The Perdix drone swarm, developed by MIT and the Pentagon, represents a fundamental shift in warfare. Each Perdix drone is tiny, just 6.5 inches long, but they don't operate individually. They form a collective brain. In 2017, 3 FA-18 Super Hornets released 103 Perdix drones that immediately began communicating with each other, forming patterns, and making decisions as a group. If several drones are destroyed, the swarm adapts instantly, changing its behavior to complete the mission. This isn't just a new weapon, it's a new category of weapon. Traditional defenses are designed to hit large, predictable targets. How do you stop hundreds of small, coordinated drones approaching from multiple directions? The Perdix swarm demonstrates how tomorrow's battlefield won't just feature bigger or faster weapons, it will include systems that operate with collective intelligence. And that changes everything about how wars will be fought. 5. Type X Robotic Combat Vehicle. The tank has dominated land warfare for a century, but what if you could get the same firepower without risking human crews? And what if it cost a fraction of a traditional tank? The Type X from Milrem Robotics weighs just 12 tons, 1/5 the weight of an Abrams tank, but packs a 50mm cannon capable of taking out most armored vehicles. It can sprint at 50 miles per hour, twice as fast as most tanks, and operate for 24 hours without refueling. With no crew compartment needed, the Type X has a significantly lower profile than traditional tanks, making it harder to spot and hit. And because there's no human inside, it can take risks no commander would order for a crewed tank. Most revolutionary is the price tag. At roughly $1 to $2 million, armies could field 5 to 10 Type X vehicles for the cost of one main battle tank. This means swarm tactics become possible, overwhelming enemies with multiple combat vehicles attacking from different directions. The Estonian Defense Forces are already testing the Type X, and several NATO countries have expressed interest. Could this robot tank make the 80-ton beasts that have dominated battlefields since World War II obsolete? Military planners around the world are betting it might. 6. Orca XLUUV, extra-large unmanned underwater vehicle. The depths of the ocean remain the most secretive battle space on Earth, but a new breed of robotic submarine is changing that. Boeing's Orca XLUUV, extra-large unmanned underwater vehicle, is essentially a 51-foot-long robot submarine that can operate completely autonomously for months at a time. Unlike previous underwater drones tethered to surface ships, the Orca can travel thousands of miles on its own. With its modular payload system, the Orca can be configured for intelligence gathering, mine deployment, anti-submarine warfare, or even strike missions, and it can do all this while remaining virtually undetectable. The U.S. Navy has already ordered 5 Orcas at a cost of $274 million, a bargain, compared to the $3 billion price tag of a Virginia-class submarine. The math is simple. For the cost of one manned submarine, the Navy could deploy a fleet of 50-plus autonomous underwater vehicles. What makes the Orca truly revolutionary is how it changes the risk calculation in naval warfare. Losing a $50 million underwater drone is unfortunate. Losing a $3 billion submarine with 135 sailors aboard is a national tragedy. The Orca allows missions considered too dangerous for manned submarines. As these systems enter service, they're creating a new undersea battlefield where autonomous systems battle for control of the depths. And whoever masters this technology first gains a critical advantage in future conflicts. 7. Boston Dynamics Atlas. Can robots move like humans? The answer becomes clearer every time Boston Dynamics releases a new video of Atlas. Standing 5 feet tall and weighing 190 pounds, Atlas is the world's most advanced humanoid robot. Unlike other military robots designed for specific tasks, Atlas represents something different: versatility. Atlas can run, jump, perform backflips, navigate obstacle courses, and manipulate objects with increasing dexterity. In recent demonstrations, It performed complex parkour routines that would challenge trained human athletes. While Boston Dynamics insists Atlas is just a research platform, its military potential is obvious. A robot that moves like a human can operate in environments built for humans' buildings, ships, and vehicles without requiring special accommodations. The Pentagon's Defense Advanced Research Projects Agency, DARPA, funded Atlas's early development. While it's not currently weaponized, its capabilities are improving at a pace that concerns many experts. A humanoid robot that can move like a special forces operator represents a significant leap in military robotics. Even if Atlas itself never sees combat, the technologies pioneered in its development will influence the next generation of battlefield robots. And that generation is coming faster than most people realize. 8. Mantis, modular, autonomous, and network-capable targeting and interception system. Air defense has always been a high-stress, split-second business. But what happens when you take humans out of the decision loop? Germany's Mantis system represents the leading edge of autonomous air defense. This automated CRAM, counter-rocket, artillery, and mortar system can detect, track, and shoot down incoming threats without human intervention. Using radar and optical sensors, Mantis detects projectiles at ranges up to 3 kilometers. Its advanced AI distinguishes threats from non-threats like birds or civilian aircraft and makes firing decisions in milliseconds. Its 35mm automatic cannons can fire 1,000 rounds per minute, creating a wall of air-bursting ammunition that shreds incoming projectiles. The German armed forces have deployed Mantis to protect bases in high-threat areas. But what makes the system truly revolutionary is that it operates autonomously. While human operators supervise the system, Mantis can function independently if communications are jammed or operators are incapacitated. This raises profound questions. Are we ready to let machines make life and death decisions? Mantis represents the reality that in some military domains, human reaction times are simply too slow. The future of air defense isn't just automated, it's autonomous. 9. The MIS, Tracked Hybrid Modular Infantry System. History was made in 2019 when Estonia deployed the Themis unmanned ground vehicle to Mali, the first time a truly autonomous ground combat vehicle saw action in a conflict zone. Built by Robotics, the Themis looks deceptively simple, a flat platform with tracks on either side. But this simplicity is its genius. The platform can accept almost any payload: machine guns, missile launchers, surveillance equipment, cargo, or even casualty evacuation stretchers. Roughly the size of a small car but much lower to the ground, Themis can operate for 10 hours on a charge, navigate autonomously using AI and sensors, and carry payloads up to 1,650 pounds. It can be controlled remotely or programmed to follow waypoints independently. In Mali, Themis supported Estonian troops in a counter-terrorism operation, demonstrating how robots can reduce risk to human soldiers. Since then, 9 countries have purchased the system, and it's been field-tested in Ukraine. What makes Themis revolutionary isn't just its capabilities, it's its adaptability. One platform can serve as reconnaissance, fire support, logistics, or medical evacuation, depending on the mission's needs. For military planners, this modular approach represents a new paradigm in ground forces. The 10th Kratos XQ-58, a Valkyrie fighter jets, cost $100 million and take years to train pilots. But what if AI could fly missions alongside human pilots at a fraction of the cost? The XQ-58A Valkyrie, built by Kratos Defense, represents a new concept: the loyal wingman. This jet-powered drone is designed to fly alongside manned aircraft, taking risks no human pilot would be asked to take. With a 2,450-mile range, 652 miles per hour top speed, and internal weapons bay capable of carrying precision munitions, the Valkyrie has fighter-like performance. But its real advantage is cost at $2 to $3 million each, The Air Force could buy 30 to 40 Valkyries for the price of one F-35. This means entirely new tactics become possible. Need to overwhelm enemy air defenses? Send a swarm of Valkyries ahead of manned aircraft to draw fire and identify threat locations. Need to extend your sensor range? Deploy Valkyries as forward observers that feed data back to human pilots. The Air Force has already conducted successful tests where Valkyries fly formation with F-35s and F-15s. The next step is teaching them to operate semi-autonomously, making decisions based on the mission parameters and threat environment. The Valkyrie points toward a future where human pilots command swarms of AI-driven aircraft that multiply their effectiveness. It's not replacing pilots, it's transforming what they can accomplish. 11th, REMUS 600. Autonomous underwater vehicle minefields have decided naval battles since sailing ships carried cannon. But finding and clearing mines remains dangerous and time-consuming, or it did, until the REMUS 600 arrived. This torpedo-shaped autonomous underwater vehicle from Hydroid/Kongsberg has revolutionized mine countermeasures. Measuring 11 feet long and weighing 700 pounds, REMUS can dive to 1,500 feet and operate for up to 24 hours on a charge. Using synthetic aperture sonar, REMUS creates detailed maps of the seafloor, identifying objects as small as a baseball at ranges up to 200 meters. Once it detects a potential mine, it can circle back for closer inspection, taking high-resolution photos to help human operators classify the threat. The U.S. Navy and over 20 other navies have adopted REMUS, using it not just for mine detection, but for intelligence gathering, underwater archaeology, and environmental monitoring. During the Iraq War, REMUS vehicles cleared shipping channels in Qasr Harbor in 16 hours, a task that would have taken human divers weeks and likely cost lives. The real impact of REMUS and similar systems is how they've changed naval operations. Tasks once considered high risk are now routine. Areas once considered too dangerous can now be secured quickly, and this capability will only grow as these systems become more autonomous. 12th IAI Harop. What's more terrifying than a missile? A missile that can think, wait, and choose its own targets. Israel Aerospace Industries Harop represents a new category of weapon called loitering munitions, often called suicide drones. Unlike traditional missiles that must be launched at specific targets, the Harop can patrol an area for up to 6 hours, searching for targets on its own. With a wingspan of 9.8 feet and weighing 440 pounds, including a 51-pound warhead, Harop can be launched from ground containers, ships, or aircraft. Once airborne, it can operate in fully autonomous mode, using electro-optical and infrared sensors to identify enemy radar systems, air defenses, or other high-value targets. When it finds a target, Harop can attack immediately or relay video to human operators for final approval before striking. The entire aircraft becomes the weapon diving into the target at high speed. Harop has seen combat in multiple conflicts, including Azerbaijan's 2020 war with Armenia, where it proved devastatingly effective against air defense systems. Its long loiter time and autonomous capabilities make it nearly impossible to defend against using conventional means. The strategic impact of systems like Harop extends far beyond their direct effects. They create uncertainty for enemies who know these drones may be circling overhead, waiting for them to activate radar or communications equipment. This psychological pressure changes battlefield behavior in ways traditional weapons cannot. 13th, T-14, Armata with autonomous capabilities. Russia's entry into the autonomous warfare race comes in the form of its next-generation main battle tank, the T-14 Armata. But calling it just a tank misses what makes it revolutionary. The T-14 is the world's first tank with a fully unmanned turret. All 3 crew members sit in a heavily armored capsule in the hull, controlling the weapons remotely. This arrangement not only improves crew survival chances, but also paves the way for future fully autonomous operation. Russia's military has confirmed they're developing an unmanned version of the T-14 that would operate without any crew at all. Using artificial intelligence and a suite of sensors including radar, thermal imaging, and traditional cameras, this autonomous version would be capable of identifying targets, navigating complex terrain, and coordinating with other vehicles. While Western analysts debate the Armada's current capabilities, especially given Russia's performance in Ukraine, what's significant is the direction it represents. Even tradition-bound Russia is moving toward autonomous ground combat vehicles. The T-14 shows that the transition to robotic warfare won't necessarily be abrupt. Instead, existing platforms will gradually incorporate more autonomous functions until human operators become optional. This evolutionary approach may ultimately prove more successful than developing completely new robotic systems. 14th, DARPA Offset Program. Urban warfare has always been the most challenging battlefield environment. Buildings block sensors, create ambush points, and make communication difficult. But what if you could flood a city with hundreds of autonomous robots working as a team? That's the vision behind DARPA's Offset, Offensive Swarm-Enabled Tactics program. Unlike other systems on this list, Offset isn't a single platform, but an ecosystem of aerial and ground robots that work together to dominate urban environments. Offset envisions swarms of 250-plus robots that can scout buildings, create real-time maps, identify threats, and even neutralize enemy forces. Human operators wouldn't control individual robots, but would issue commands to the entire swarm, which would then decide how to accomplish the objectives. In demonstrations, offset swarms have shown they can clear city blocks faster than human forces while keeping soldiers safely behind cover. The swarms adapt to losses, rerouting and reconfiguring as individual robots are disabled. What makes Offset particularly significant is how it changes urban tactics. Historically, attacking forces needed a 3-to-1 advantage to take urban areas. Robotic swarms could flip this equation, allowing smaller forces to control cities by multiplying their presence with autonomous systems. As urban areas become the primary battlegrounds of the 21st century, programs like Offset represent the future of military operations in complex environments. 15. Multi-Utility Tactical Transport, MUTT. The average infantry soldier carries over 100 pounds of equipment. This burden exhausts troops and limits their mobility. But what if they had a robotic pack mule that could follow them anywhere? The multi-utility tactical transport from General Dynamics addresses this challenge directly. This 8x8 or tracked unmanned ground vehicle can carry 1,000 pounds of equipment, follow soldiers autonomously, and provide mobile fire support when needed. Already in use with the U.S. Marine Corps, MUTT can operate for 60-plus miles on a single charge. It navigates using a combination of GPS, computer vision, and a follow-the-leader function that lets it trail behind soldiers without requiring active control. What sets MUTT apart is its versatility. Need to evacuate wounded soldiers? MUTT can carry stretchers. Need fire support? Mount a machine gun or javelin missiles. Need to resupply isolated troops? MUTT can reach them even in rough terrain inaccessible to larger vehicles. The practical impact of systems like MUTT cannot be overstated. Throughout military history, logistics has often determined outcomes more than tactics. By allowing infantry to bring more ammunition, water, batteries, and medical supplies into battle, MUTT doesn't just support the mission, it makes previously impossible missions achievable. The robot revolution isn't some distant future, it's reshaping battlefields right now. From Turkish drones over Nagorno-Karabakh to robot dogs patrolling Air Force bases, autonomous systems are becoming central to military operations worldwide. These technologies aren't just changing how wars are fought, they're changing the calculations about when and why countries go to war. As the human cost of conflict potentially decreases, other factors may drive military decision-making. One thing is certain, there's no going back. Just as tanks, aircraft, and nuclear weapons transformed previous eras, autonomous systems are defining warfare in our time. And we're just seeing the beginning of what's possible. If you found this exploration of military robotics eye-opening, make sure you're staying informed about these rapid developments. Hit that subscribe button and turn on notifications so you don't miss our upcoming coverage of breakthrough military technologies. And share this video with anyone interested in how technology is transforming warfare. They'll thank you for the insights. Leave a comment with which of these systems you think will have the biggest impact, and I'll see you in the next video.